We are looking at identifying graphs of log functions today. Before we do that, I want to go back and revisit some of the things we did when we were identifying graphs of exponential functions. Why might I want to do that first?
Because they're inverse.
They're inverses, that is correct. So they will be somewhat related. So when I was finding exponential functions, when we were identifying graphs of exponential functions, what were some of the things we identified? The horizontal asymptote. We identified shifts.
The range.
We identified the range. Picked out a couple points. Okay, and somebody mentioned somebody in first hour mentioned the base. How does the base affect me?
It never changes.
It never changes, and it has steepness. So, keeping that up there, let's talk about what's going to happen on log functions. I had horizontal asymptote on exponential functions. So what am I going to have on a log function? I'm going to have vertical asymptote on log functions. Okay, I had shifts on exponential. I'm still going to have shifts on logs. We identified the range on exponential functions. I'm going to identify the domain on log functions. Got some points on exponential. We're still going to do points over here. And the base is always the base. So it's still going to be the base over there. Now, oops. Alright, so there's a general form of an exponential function, and we talked about each one of those pieces the other day when we were dealing with exponential graphs. So what do we say about our x values?
They're the
What
same
could
as
they be?
logs.
What could they be?
All
All real numbers. So my x values could be negative infinity to infinity. What do we say about the base?
Greater than 1. Can't equal 3.
Can't be 1 and greater than 0. And what do we say about the y? We said our y had to be 0 to infinity. So, if I go to a log, we can now identify each piece of the log after we have identified it on the exponential. So, what must be true about the x? 0 to infinity. The base is always the base, so that has to be not equal to 1 and must be greater than 0. And then what about the y? Negative infinity to infinity. So that means in this spot right here, we're only allowed to have what? Positive numbers. We are only allowed to have positive numbers in that spot. So that we need to remember that with what we're doing today. So we're going to identify our shifts. We're going to find our vertical asymptote. That's going to help me figure out my domain, a couple points, and then we'll use that to identify our graphs. That's what we're planning on doing today. All right. So let's just start with something basic so that we can get the general idea of what a graph of a log function is going to look like. So I want to graph y equals log base 2 of x. So on this one, there are no shifts. And on exponential functions, if I didn't have any shifts, where did I know my range was?
0.
0 to infinity. So if I'm dealing with a log and I don't have any shifts, that tells me my domain is going to be 0 to infinity. So I know my domain is 0 to infinity. Okay, and also on an exponential function, if I didn't have any shifts, my my horizontal asymptote was always 0. So if I don't have any shifts here, that tells me my vertical asymptote is always 0. So I have a vertical asymptote at x equals 0. So now let's pick out a few points. So remember, what do my points have to be if I'm plugging in for x? They have to be positive. So what's a good number to plug in for x? 1. So what is log base 2 of 1 going to equal? 0. Remember, the log of 1, no matter what my base is always 0. All right, what's another good number to plug in? 2 is a good one. So I plug in 2. That gives me log base 2 of 2. What is log base 2 of 2? 1. Okay, here's where you have to start using your brain a little bit on what you want to plug in. 4 is what I want to plug in next. And what do I get out of that? 2. Why did I choose 4? Because 2 squared equals 4. So Rain, what's the next thing I want to plug in?
16.
There's one in between.
9.
8. Okay, what does 2 represent? 2 to the first. 4 represents 2 squared. 8 represents cubed. So the numbers I'm plugging in here are 2 to a power. Okay? So that's what you need to make sure of there. So if I plug in 8, what's log base 2 of 8? 3. So what would the next x value I plug in be? 16. But obviously 16 is a pretty big number, so I don't need to go there. So let's see what we have so far. Alright, so I've got 1, 0, and 2, 1. So there's 1, 0. There's 2, 1. Then I have 4, 2. Then I have 8, 3. So 5, 6, 7, 8, and 3. So we should be able to see that we're headed that direction over there.
Why didn't, like, if you put in 1, 4, it would be like -2, so why didn't it go across the x-axis?
We will. I'm just getting there. I'm just graphing everything we have up here. Okay? But Chris brings up a great point. Notice my domain is 0 to infinity. So far, I've only graphed everything from 1 to the right. So I need to know what's going on between 0 and 1. Since I've got an asymptote, what are my only options as something gets closer to an asymptote? What does my graph have to do?
Go up and down.
It has to go up or it has to go down. In this case, what does it look like it's going to do? So it's going to go down. So let's plug in 2 more points just to verify it's going to go down. So what's another number I want to plug in that's between 0 and 1?
Negative.
1/2 is a good one. Okay, now how can I rewrite 1/2?
2 to the
2 to the negative 1. So if I have log base 2 of 2 to the negative 1, what's that going to equal? Negative 1. So I have 1/2 and negative 1, which is right there. And let's throw one more number in there. 1/4 would be a good one. How can I rewrite 1/4? 2 to the negative 2. So log base 2 of 2 to the negative 2 is negative 2. So 1/4 and negative 2 somewhere in there. So it does verify that this thing is going to go that direction. So there's the general shape of it.
So would you like that? like if we're doing graphs, you want us to make sure double check upon that.
Well, we're gonna do what we've been doing with graphs the last couple weeks is I'm gonna give you graphs and you gotta go figure out which one it is. Okay. All right, so let's talk about the shifts. Let's talk about what happens when or what adjustments are made to get a shift. All right, so we're doing log base 2. All right, so there's a graph which matches what we just did. So what are some things we can do to shift it? Plus 1 where?
On the outside.
On the outside. So I could do plus 1 there, and you're going to tell me it's moving up 1.
It's gonna be
I press enter, so it did move up 1. Now I want you to notice something. The plus 1 does not have to be in the back. The plus 1 could be in the front. So I could do 1 plus, and it's still going to move it. It's still going to be in the same spot. So I could have the 1 plus in the front, or I could have the plus 1 in the back. Either way, it still moves it up or down. All right, what else can I do?
subtraction outside and move down.
All right, so if I subtract on the outside, it's going to move down. I agree with that. So we've got the up and down taken care of. What else can we do?
You put it negative in front of the log.
Negative in front of the log. What's that going to do, Skylar?
It's going to flip it over the X.
Flip it over the x-axis. So it flips it over the x-axis. So there's that.
If you change the base. No, base.
No, I don't want to change the base. Base is always the base. What else?
You can put plus or minus inside of the.
So I could do plus 3 on the inside. What's that going to do?
Move it left 3.
Move it left 3. So that moves it left 3. Just like everything else we've done this year. If we do something inside, it moves me left or right. If we do something on the outside, it moves me up or down. All right, and one more thing.
You put the negative in front of the X.
So we want to put a negative on the inside. What's the negative on the inside going to do?
Flip
Flip it
it over the Y.
over the Y. So instead of going to the right, it's going to go to the left. So there it is. So there's all the shifts we're interested in. Now, when we dealt with exponential, there was one type of shift that affected my horizontal asymptote and my range. What shift affected my horizontal asymptote and my range?
Up or down.
Vertical, up or down. Okay? On logs, we're dealing with the domain and we're dealing with vertical asymptotes. So what shift is going to change my domain and my vertical asymptote? Left and right. So if I don't have a left or right shift, my vertical asymptote is always going to be 0. Okay? Alright, so let's do a few of these. I have log base 4 of negative x plus 3. Log base 4 of negative x plus 3. So let's take care of the shifts first.
Flips over the Y.
Over the y,
To the left 3.
and left 3 is incorrect.
Right.
It needs to go right 3. Remember, if there's a negative there, we want to factor that negative out. Make it x minus 3. So that shows me it's going to the right 3. All right. What about my vertical asymptote? What's it going to be? 3 is correct. Because remember, my left or right shift affects my vertical asymptote. So since I went right 3, that's where my vertical asymptote is going to be. Okay, then my domain. Just like when we were doing the range with exponential, either infinity or negative infinity has to be a part of my domain. So I need to know, is this thing going to the right or is it going to the left?
Left.
This one's going to the left. Why is this one going to the left? Because it flipped over the y. So since it's going to the left, do I want infinity or negative infinity?
Negative infinity.
Negative infinity. So negative infinity has to come first, which means the 3 has to be in the other spot. So if it's going to the right, we're using infinity. If If it's going to the left, we're using negative infinity. Alright, then I want to pick out a couple points. Okay. So there are two things I want that right there that I've underlined. There's two numbers I want that to be. What's the first number I want that to be? 1. Because any log of 1 is always 0. So the first thing I want to do is, what x will make that 1? What can I plug in for x that'll make that 1?
2.
2 will. Because if I plug 2 in, that gives me negative 2 plus 3, so that makes my log 1. So if I plug 2 in, I'm dealing with a 1. What is log base 4 of 1? 0. So that means my first point is 2, 0. Alright, what's the other thing I want that to be? I want it to be equal to my base. Okay, so the next thing I want is I want this to be equal to my base, which is 4. So what does x need to be in order for this to be 4?
Negative 7.
Negative 1. So negative 1 with another negative makes it
Positive.
1, and 1 plus 3 is 4. So what is log base 4 of 4? 1. So when we go to our graphs, we're looking for something, since it's over the y, we're looking for something that goes to the left and has a vertical asymptote at 3 and also has these 2 points on it. And if we match all that up, we've got what we're looking for. Alright, so we said it's going to the left. So those first 4 are no good. I've only got one that goes to the left, so it has to be that one. Is the vertical asymptote at 3? Yes. And what were my 2 points? 2, 0 looks good.
-1.
And -1, 1 looks good. Now keep in mind that there are arrows on each of these. Okay? It continues to go down and it continues to go to the left. Okay, so we've got our match, we like that. Let's try 2 more. We'll have log base 3 of x plus 7 minus 2. Log base 3 of x plus 7 minus 2. So it's going down 2. Left 7. So what is my vertical asymptote?
-7.
X equals -7. Which way is this graph going? To the right or to the left? It's going to the right, so what's going to be a part of my domain? Infinity or negative infinity? Infinity. So infinity has to be on the right, so what's got to be on the left? -7. So now I'm ready for some points. So I want that to be 2 things. I want it to be 1, and I want it to be what in this case? I want it to be 3. So what does x need to be in order for that to be what? -6 plus 7 is 1, right?
Yeah.
So it needs to be -6. So what is log base 3 of 1? 0. And what is 0 minus 2? -2. So that point is -2. So you evaluate this thing, and then you worry about what's on the outside. So I plug -6 in. That makes the log equal to 0, and then 0 minus 2 gives me the -2. So the other thing is I want this to be 3. So what x would make that equal to 3? -4. So -4 plus 7 gives me 3. What is log base 3 of 3? 1, and 1 minus 2? -1. So there are my 2 points I'm interested in. So I know this thing is going to the right. I know it's going to the right. It should have a vertical asymptote at -7, and then these points should match up. so it's going to the right, -7. That one looks like it might be -7. What are my 2 points?
-6,
-6, -2 matches up, and what's the other one?
-4, -1.
-4, -1 matches up as well, so we like that. We've got a match. One more. All right, y equals negative log base 2 of x plus 5 and then plus 1. And just as a reminder, to make sure we're all on the same page, all of this right here is on the same level. The 2 is the only thing that's not on the same level. So what are my shifts? Up 1, I heard over the x. Left 5. All right, so vertical asymptote. X equals -5. And then we're ready for my domain. Which way is this thing going? To the right or to the left? It's going to the right. How do I know it's going to the right? There was no, it did not flip over the y. In order for it to go to the left, it's got to flip over the y. This did not flip over the y. So that means it's going to the right, which means it's got to have infinity on it, which means the other spot has to be -5. So then we get our 2 points. All right. So we're interested in this right here. What's the first thing I want that to be? 1. So what makes it 1? -4. All right, so I put -4 in there. That makes that 1. What is log base 2 of 1? 0. What's 0 times -1?
0.
0. And 0 plus 1?
1.
1. So I have the point -4, 1. All right, what's the next thing I want that to be? I want it to be 2. So what does x need to be to make that 2? -3. So I plug in -3, it makes this 2. What's log base 2 of 2? 1. -1. -1 plus 1? 0. So we know it's going to the right. Our vertical asymptote is at -5, and then it should match those 2 points. So to the right, -5. To the right, -5. There's one that's at -5. What are my 2 points?
-4 and 1.
-4 and 1 matches, and the other one?
-3 and 0.
-3, 0 matches. So we like that one as our match. Okay, so we're looking for shifts. We're looking for our vertical asymptote, our domain, 2 points. From all that information, it should be easy to find the match. Questions on that? All right.